we add 5/6 to both sides. So you get y plus 5/6 equals x cubed. We take the cube root of both sides. And so we have cube root of y plus 5/6 equals x. So once x is by itself, you switch the x and the y, so you have cube root of x plus 5/6 equals y. And then now that you have y by itself, you change the notation to function notation. And so that's our proposed answer right there. So we're going to now prove that it's the right answer by using composition. So I'm going to take f of x, okay, and then replacing the blank or filling in the blank with f inverse of x. Okay, so now cubing the cube root gets rid of the radical. So then I have x plus 5/6 minus 5/6. So the 5/6 are gone, and you're left with x. Doing the other direction, f inverse of f of x, you start off with cube root of blank plus 5/6. So in the blank goes f of x. So it's x cubed minus 5/6. Okay, so now what happens if 5/6 cancel out? It's a 0. And so you have cube root of x cubed. So that gives you x. So f inverse of x, okay, is correct. Same, I got tired of writing, same as number 9 and 10. So now we're going to graph. Okay, so I've transformed the points. I'm using the 5 points initially, but then sometimes I don't graph them because of space limitations. So the negative 5/6 is your k, so that brings the graph down by 5/6 units. So you see the points in pink, those are the transformed points. Now I outlined the yellow ones because those are the ones I'm going to graph. Okay, so for the f of x, I'm using pink. So negative 1, negative 1, and 5/6. So negative 1, negative 1, and 5/6 is approximately right here. 0, negative 5/6. So that's again approximately right here. And 1, 1/6. So 1 and 1/6 is approximately right here. So connect your points. And then switch them for the inverse. So instead of negative 1, negative 1, and 5/6, it's going to be negative 1 and 5/6, comma, negative 1. So negative, comma, negative 1, so about here. Negative 5/6, 0. Here. And then we have 1/6, 1. So 1/6, 1 is about here. Okay, and so this one goes out. And out. Okay, and that's the function. Alright, so we're going to find the inverse. So again, same 4 steps. Y equals x cubed plus 9. So we're going to subtract 9. So y minus 9 equals x cubed. So now I'm going to take the cube root of both sides. And by doing that, I've eliminated the radical on the right side. So now I have x. Now that it's by itself, we're going to switch the x and the y. And then now that y is by itself, we change the notation. Okay, so this is our proposed answer. We're going to use function notation to, composition, sorry, to prove that it's right. So I have enough space right here, so I'll just start here. So f of f inverse of x means that I'm going to take f of x and replace the x with f inverse of x, or at least my proposed f inverse of x. So this shows that the radicals cancel, so I have x minus 9 plus 9. The 9's cancel, so I'm left with x. And so you do the other direction. So this is cube root of blank minus 9. And in the blank, the x is replaced with f of x. Okay, so then the 9 minus 9 cancels, so you're left with cube root of x cubed, which is x. And so you just say the same reason as the other ones, where because the compositions both equal x, then we know that the functions are inverses of each other. Okay, so I made the graph big enough so that all 5 points fit. So let's start off by graphing f of x. So negative 2, 1, negative 1, 8, 0, 9, 1, 10, and 2, 17. So the graph goes like this and then up like this. So this is f of x. So we're switching the points. So the first one is 1, negative 2, then 8, negative 1, then 9, 0, then 10, 1, then 17, 2. And so curve out like that, and then curve down. Yes, I missed the point slightly. It's not a big deal. So this is f inverse of x. Okay, so this is a work of a student who was asked to find the inverse. We have to find the mistake and then fix it to get the right inverse. So step 1 looks good. He did switch out the f of x to y. The next thing is subtract 9. Subtract the 9, and he did that. It's right there. Then he had to take the cube root, and I think it looks like he got rid of the 2 right here first, which is wrong. Okay, so what he should have, so the mistake is right here. This is the error. He or she multiplied by 2, but it's too early because it's still cubed. You have to get rid of the cube first. So what should have happened here is cube root of y, cube root of x over 2 cubed. That's what should have happened. Okay, so you get cube root of y equals x over 2 because the radical's gone. Now you multiply by 2. And because it's outside of a radical, you have to put it in front of the cube root of y. So now that x is by itself, you switch the x and the y. Oops, I keep forgetting to switch it out. And now the y it's by itself, change it to function notation. So this is what the answer should be.